In this video, I will explain the solution to LeetCode problem number 112, path sum. We are given the root of a binary tree and a target sum. We must check if there is a root to leaf path in the tree so that the sum of all nodes in the path equal the target. Keep in mind that a leaf is a node with no children. In this example, we are given that target sum equals 22. If we look at the nodes highlighted in blue, we see that their values add up to 22, which is our target sum, meaning the path exists, so our algorithm returns true. In this example, we are given that target sum equals 5. One possible root to leaf path is 1 and 2, or 1 and 3. The sum of either path does not equal 5, so false should be returned. Our last example tells us that if our root is null, or we're given an empty root, then we should return false, because there are no root to leaf paths. We know that if we are given an empty root, we should return false. But what should our other base case be? Since we're looking for root to leaf paths, our second base case will be when we hit a leaf node, which in code looks like this. This should return true because our only node is equal to the target. When we have multiple nodes, notice how if we subtract the current node's value from the target sum and check the subtrees using recursion with that new target, when we reach our leaf node, that leaf node's value should equal the new target. When we enter 3, our new target will be the previous target value minus the previous root's value. So we check our subtrees with a new target each time subtracting the current root's value. So when we enter 3, target becomes 3. 5 minus 2. If they are equal, that means the tree had a path where our target was reduced by exactly the same numbers needed to be equal to the sum. The algorithm recursively checks the left and right subtrees, with each recursive call sending the target to be the target minus the current root's value. If our tree does have a solution, it will eventually hit a leaf node and compare its value with the updated target and return true or false if they are equal. In this case, 3 equals 3, so true is returned. We come back to 2. Our left subtree returned true because 3 equals 5 minus 2. We then check the right subtree of 2, which returns false because it's null. And since we're looking for root to leaf paths, we can have a solution in our left subtree or our right subtree, so the OR comparison operator is used. Our left returned true and our right returned false. So true is returned and the problem is solved. Let's apply the concept to a more complex example. We are given that target is 22, so we recursively checked our left subtree with the new target as 17. Again, we subtract the root's value from the target, so we enter 11 with target as 13. Next, we move to node 7 with target being 2. We hit a leaf node, we compare its value, and 7 does not equal 2, so we return false. Come back to 11, 7 returned false, so we check 11's right subtree with target being equal to 2. 2 equals 2, we have a solution and we return true up the call stack and the problem is solved.